Hi, my name is John. Welcome to part 2 in the review of this Artec 160 inverter TIG welder. In part 1 of the review, I showed you how to hook the welder up to a power supply, what all the various knobs and switches did, how to hook a gas bottle up to it. We did a little bit of welding on straight DC. In this part of the video, I'm going to concentrate on the more advanced side of the welder, that is to say the pulse side. Pulse welding was invented for welding thin materials, especially stainless steel and exotic materials, titanium, Inconel, that sort of thing. Saying that, you can also weld mild steel with it. Basically, pulse welding is just that. It puts a pulse of power in and then backs off. Pulse, back off, pulse, back off. This can happen at various speeds depending on what you're welding. The effect it has is it puts less heat into the weld. So in theory you get more penetration for less heat. That's what it's all about. That's the idea for welding thin material. More penetration with less heat, less distortion. You can't go wrong. Well, you can. I'm going to bring the camera in and show you the control panel. This little bit here, that's where all the pulse settings are. I'm going to concentrate on the pulse welding side of things. These are the 3 control knobs that control your pulse settings. There's one switch there, it either turns the pulse on or off, or has a low rate of pulse or a high rate of pulse. This knob here controls your pulse rate or your pulse frequency. It goes from 1 pulse every 2 seconds up to 20 pulses per second, and then from 25 pulses per second up to 250 pulses per second on the low and high range. This one here says pulse amps. If you set your welding amps at 100 amps, you're going to get a 100 amp pulse, then it's going to drop down to whatever you set this at. Normally about 25% your main amps. So you're going to have a burst of 100 amps, then off to 25 amps or whatever you set it to. This one here is a pulse time on. That decides how long the high end is going to be on for. Is it going to be a long pulse of high power, then a short piece? Or is it going to be a short burst and then a long piece inside your actual period of the pulse? So we'll recap on that. Pulse frequency, how often it happens, pulse amps, what it drops down to from your high amp setting or your basic amp setting, pulse time on, is it going to have a long time at high power or a short time at high power? Simple as that, that's the way it is, that's the way they work. This one is analog, like it's got knobs, some of them are digital. Personally I do prefer knobs like this, it just depends. Right, I'm going to turn the machine on, you'll hear the fan running, and I'll show you the operation of this little pulse switch, and then basically I think we're going to do some welding. Right, so it's powered up. So we'll set our basic welding amps to 100 amps. Pulse is turned off there. That's a low rate of pulse, and that's a high rate of pulse. 2T, 4T. We're on 2T because I'm using a foot pedal. We're on TIG welding, the other one's for stick welding, and we're on high frequency start as opposed to lift start. I've changed the torch that Artec supplied with the welder for this one. This is a CK torch, a WP9. Artec also supplied this. This torch just makes it easier for me to video welds because it's got a gas lens on, and I can have a lot more stick out of the tungsten so I can see what I'm doing, or at least the camera can see what I'm doing, hopefully a little bit better. To me, this torch is the ideal setup for this welder, for welding thin stainless steel like exhaust material up to about 125 amps. I've got a bit of 2mm stainless set up here. I'm going to run some welds on it. The first one will be straight DC, then 1.5 pulses a second, 20 pulses a second, 100, then 250 pulses a second. The material is 2.5mm thick stainless steel. I'm going to use 80 amps as a basic weld setting, and everything will be on full pedal, so it'll be the same power setting for each weld. Right, the first weld A straightforward DC weld, no filler, at 80 amps, no filler. Do one more, same setting, 80 amps, straight DC. The next weld is 1.5 pulses a second. Once again, full pedal, 80 amps. Do another one. Right, this weld is 20 pulses per second. One more. Difficult to concentrate at that sort of full shape. Right, this one, 100 pulses per second. Much tighter off. Do another one. Right, next one is 250 pulses a second. One more. Right, that's the first one, straight DC at 70 amps. Next one is 1.5 pulses a second with no filler where you can see how it's creating the ripples, the so-called stack of dime looks. Next one along, that one is at 20 pulses a second. You can see how it's tightened the arc up and has less heat. The heat affected zone is a lot less than these ones, has more heat dissipation than there is on that one. Go along again. Next one, 100 pulses a second. See the arc's even tighter and there's less heat affected zone around the weld. And then finally we'll come up to, that's 250 pulses a second, still on 80 amps. And you can see there's hardly any heat affected zone around it. The arc is much tighter. I've set up a lap joint in 2mm stainless steel. I'm going to do the first weld on straight DC. The material is 2mm thick, and if you work on 30 amps per mil, I've set the amperage at 60 and I'm going to go full pedal, one weld straight down there. the second part of the weld. I'm going to do on pulse, slow pulse at 1 pulse a second. I'm just going to lay the rod in to the joint and let the pulse do its thing. It was a bit straight towards the end, that was me, not the... This is the same material, the same weld, except I'm going to weld this one at 125 pulses a second. That's the only thing I'm changing, just the pulse frequency. Still weld on full pedal, full ampage. This time it's turned up to 250 pulses per second. You can see straight away it's a much tighter, hotter arc. It really is nice to weld with. Right, there are the 4 welds. That one there straight DC. That was a slow pulse. 125 pulses a second and 250. On these two you can see that the heat affected zone on the 125 is wider than on the 250. The 250 is a much tighter, finer arc. That's the one I prefer to weld on. It's tighter than the DC. The pulse is not ideal for this particular job. Where the pulse comes in handy is on an edge, like a corner joint or an edge joint where you don't need filler material. In fact, I'll set a corner joint up now and we'll run the corner joint on the straight DC and then on the 1 pulse per second. Right, this is an outside corner joint. I'm going to weld it at 60 amps straight DC. Once the weld starts, you don't need any filler wire, just glue it together quite nicely. Right, this time we're on the slow pulse, 1 pulse a second. The bottom end of a welder is really important, like how low it'll go. These are box cutter blades. I've got the machine set at 20 amps. I've got some 1mm filler wire. Let's see if I can weld these together. Look at that. Nice clean, crisp start. Some thinner filler wire. Right, that's a razor blade welded. Obviously it's gone right through. And I'm sure you'll agree that pulse welding actually works. It is quite a handy tool, it's not just a gimmick. And the next part of the series on this little welder. I'm going to do some MMA welding, some stick welding, because I do like a bit of stick welding. This is the setup I use for videoing welds. So if you wonder why I sometimes dip with tungsten, you can understand, because I've got all these various lights and cameras and tripods in the way. Not very good, I've missed it, I can't see what I'm doing. Bastard! Right, next is a pulse weld, 1.3 pulses a second. I'm just laying the wire in. That's that. That was for the best of us.